In this video, we are going to discuss regression lines, also known as lines of best fit, and residuals. If you are unfamiliar with regression lines and residuals, then hopefully the problem or problems below will help you get a better understanding of them. Regression lines are almost always tested on the ACT in some way or another, and residuals sometimes appear in questions that involve regression lines. So let's go through this example. A regression line for a bivariate data set of observed values is plotted in the graph below. 4 data points, A, B, C, and D, from the original data set are also plotted in the graph. The difference in y of the observed value and the value predicted by the regression line is known as a residual. So let's do that. So y observed minus y predicted equals the residual. We'll just leave that up there. So use the information in the graph to answer the following questions. Let's take a look at the actual graph here. So we have a line of best fit, and the line is actually defined for us. Y equals 2x plus 1.6. And then we have 4 points on there at coordinates 2, 4, 5, 9, 4, 11, and 3, 10. If you don't know what a regression line is, allow me to draw at the bottom how we get regression lines. So if we have a bunch of data points that we collect and we plot them on a plot, this is known as a scatter plot, we can use a technique to get a line of best fit. And the line of best fit is simply a line that is used to best interpret that data, or best predict, if we have a certain value of x, where that is going to fall on y. So that's what a regression line actually is. Residuals, again, we know that y observed minus y predicted is equal to the residual, so that is where our the residuals come from the actual data. So if we have, for example, at point A, it's at 2, 4, we know that the residual is going to be negative. So we have the residual just really going to be the distance, the vertical distance between the y values here. We know that is going to be negative because it falls below the regression line. Likewise, we know that if you are above the regression line, like at point D, we're going to be positive. So I can go through and label these positive, positive, negative, negative, etc. So that's what a residual is. It's essentially the vertical distance between an actual point and the line of best fit. All right, so with that in mind, let's actually do these problems. So let the residual for point A be represented by lowercase a, the residual for point B be represented by lowercase b, etc. So which of the following inequalities is correct? So AB is less than AD. So A times B, conveniently we've already labeled these as negative and positive. So A times B, that's a negative times a negative, which is a positive, is less than A times D. A times D, a negative times a positive, that would be a negative. So that would be a positive is less than a negative. So no, that is incorrect. B, A plus B, so that's a negative plus a negative. That's going to be a negative. And then we have A plus B on the right as well, so that's going to be a negative, multiplied by C. Well, C is positive, and it also looks like it's greater than 1. And it does look like this graph is drawn to scale. So it's greater than 1. So a number greater than 1 times the same negative, so that's going to be an even greater negative. Greater negative, or more negative. So it's kind of confusing how I wrote that, but a negative is less than a greater negative? No, that's false. So that one, it would be larger because it's less negative. Okay, so C, A times D, which is a negative times a positive. negative times a positive, of course, then negative, is greater than C plus D. C and D are both positive, so that's going to be positive. So no, a negative cannot be greater than a positive. D. DC is less than, so DC is a positive times a positive, so another positive, is less than AB times AB times, A plus B times A plus B times A plus B. So A plus B, negative plus a negative is a negative, and we have a negative times a negative times a negative then. That's going to be overall a negative. So a positive can't be less than a negative, so that one's not true. So that leaves us with E, which by process of elimination is probably true, but let's just do it anyway. So A divided by B, that's a negative divided by a negative, that's going to be a positive, is greater than CD over A. So that is a C is positive, D is positive, and A is negative, so that is a negative. So a positive is greater than a negative, yes. So there we go. Next question, which point has the residual with the greatest absolute value? All right, so that means all the absolute values are all going to be positive, so I guess we just need to figure out which residual has the greatest magnitude. So which point has the vertical distance from the line that is the largest. All right, so we can do a quick eyeball test here. A looks like it is about 1.5 from the line. C looks like it is about 1.5 from the line. D, a little over 2, and B is also a little over 2. So let's compare B and D and actually calculate the residuals. So again, we have the equation at the top, y observed minus y predicted is equal to the residual, and we want to find the absolute value. Let's do this. So B, and we'll carry over the lower cases, so the absolute value of B is equal to, we have the coordinate points are 5, 9 for B. That means the y observed is 9 minus y predicted. So let's use that equation. We have the line of best fit is 2x plus 1.6. So 9 minus 2x, so 2 times 5 plus 1.6. And of course, we're taking the absolute value of all of that. So 9 minus 2 times 5 is 10 plus 1.6, that's 11.6. So 9 minus 11.6 is 2.6. Well, it's actually negative 2.6, and then we take the absolute value of that. So that's going to be 2.6. All right, and let's take the absolute value of D. So D is at 0.310. So y observed is 10. And we are subtracting from that y predicted, which is 2 times 3, because we're at 0.310. So x is 3, plus 1.6. And that would be 10 minus, so 2 times 3 is 6, plus 1.6 is 7.6. 10 minus 7.6 is 2.4. And the absolute value of 2.4 is also 2.4. So that leaves us with the residual B has a greater magnitude or a greater absolute value than D. So point B has the residual with the greatest absolute value.